For the next set of questions, so 12 to 16, let's first figure out what kind of problem this is. Just by looking at these two right here, I can see that we're trying to find the probability within 25 of the population mean. This means this is a chapter 7 problem because we're looking for the probability. All right, so let's now read this problem and write out everything that is given to us. So we have an average of 508, so a mean of 508, 0.508. We have a standard deviation of 132. This is population standard deviation. So I'm just going to write sigma equals 132. And we have a sample of 200. So that's n equals 200. All right. Now let's take a look at 12. So the sampling distribution of X bar is normal due to the central limit theorem. That's going to be the answer. And how do we know that? Well, in this chapter, in chapter 7, we learned about the central limit theorem. You should just make sure you know the definition of what the central limit theorem is. But hint, hint, anytime you see this on the exam or anytime you see this, this is going to be the answer. Is normal due to the central limit theorem. Okay, there we go. Standard error. So how do you calculate the standard error? Standard error is standard deviation divided by square root of n. So the standard deviation divided by square root of n. This gives us our standard error. So that's going to be, we said our standard deviation is 132. So it's going to be 132 divided by square root of 200. If you were to plug this in into Excel, you're going to get 9.33. So our answer here is going to be C. The next question is saying, what is the probability? Whenever we're looking for a probability, you should know that means we're going to be using norm.dist. We're looking for a probability that a random sample of 200 broadband internet customers will provide an average that is within 25 of the population mean. So our population mean is 508. So what we need to do is we need to get our upper and lower limits. So I'm going to put UL for upper limit and LL for lower limit. Our upper limit is going to be 508, right? The population mean, plus 25, because we need to add and subtract 25 to the population mean to get our interval. So, okay, there we go. And we're going to do 508 minus 25. And when you do this, you're going to get 533 and 483. All right. Okay. Now that we have these two values, we can use that norm.dist function. So to get our probability, we're going to do norm.dist of the larger value minus norm.dist of the smaller value. So norm.dist, our X is 533, the larger value. Then we need our mean. Our mean is 508. And then it says standard error, right? If you were to plug this into Excel, you're going to get, it's going to say standard deviation. But instead of standard deviation, we need to plug in standard error. Remember that. Whenever it says standard deviation for this type of problem, for chapter 7 problem, you need to plug in standard error. So we calculated standard error right above here. So it's going to be 9.33, do comma 1. And then you're going to subtract that smaller value. So norm.dist of 483, 508, the mean, and then in place of standard deviation, you put standard error. So standard error, that's 9.33, comma 1. Put the 1 right here. And if you plug this into Excel, you are going to get 99%. You're going to get 0.9926. We're just going to round that to 99%. Turn that into a percentage. So the answer would be D. Okay. So the probability in the preceding question would blank if we were to increase the sample size. So the best way to figure this out is when you do this on Excel. Let me actually share my Excel with you guys. So let me stop sharing this. Share screen. Go here, here. All right, so you can see that I have calculated this all out. So this question is saying what's going to happen to the probability, so to this number, if we were to increase our sample size. So our sample right now is 200. We want to change it to 251. So watch what happens to this number. What I'm going to do is I'm just going to write this right here, 99260. Okay. All right, so let's change this to 251. So what just happened? It just went from 0.992 to 0.997. So we see an increase. So stop sharing. So the answer here is going to be increase. Okay. For number 16, so suppose we reduce the sample size n from 200 to 25. The sampling distribution of x bar will be normal only if the answer is going to be x is normally distributed. And that is because if our sample goes below 30, then we're only going to have a normal distribution if x is normally distributed. Just know that. So the answer would be B here. And that's how you do this set of questions.